Hi everyone. This morning we're going to review a few calculus problems, and one of them is evaluating an integral using the fundamental theorem of calculus. In this video, I'm going to do the first two problems. In another video, we're going to make it a little bit harder using u substitution. So in this problem here, evaluate an integral, and notice both of these are definite integrals. They have bounds here, upper and lower bounds. So you have to use the fundamental theorem of calculus to do this. So here in this problem, the first thing I'm going to do is I'm going to find the antiderivative. So here to find the antiderivative, 9e to the x, the antiderivative of that is just 9e to the x. Antiderivative of plus 9 sine x is plus a negative 9 cosine x. And the bounds go from 0 to pi. So remember, if it's a definite integral, you want to include the bounds. If it was an indefinite integral where there's no 0 and there's no pi, then you would just write plus c because it's an indefinite integral. But here we definitely have a bound, a left and right bound, 0 and pi. At this point, I always recommend checking my work. So what do I mean by checking? So what I'm going to do is I'm going to take the derivative of this function. If I take the derivative of this function, I should get this answer here. So if I take the derivative of this, derivative of 9e to the x is 9e to the x. Derivative of this is negative 9. Derivative of cosine is negative sine x. Therefore, this becomes 9e to the x plus 9 sine x, which indeed is this. So again, that's the definition of antiderivative. The definition of antiderivative is going the opposite direction of the derivative. So if you take the derivative of this function, you should get what you originally had in the beginning. All right, next I'm going to use the fundamental theorem of calculus, FTOC for short. And before I start plugging things in and getting my mind kind of fuzzy-wuzzy with all this stuff, I'm going to put in brackets just to really organize my work to make sure I don't make mistakes. So when I put in brackets, what I mean is I'm going to set this up to do the f of b minus the f of a. In other words, b is the pi and a is 0, so f of 0. So when I plug pi in and when I plug 0 in, this is what I end up getting. I get 9e to the pi minus 9 cosine pi. I plug 0 in, I get 9e to the 0 minus 9 cosine 0. So as you can see, by putting brackets around here, it really makes the problem a lot more simpler and less confusing so that my mind doesn't get all fuzzy-wuzzy with all the numbers and minus signs going on. So set it up by putting the brackets and the minus sign and then plugging things in. That's what I would recommend. All right, now the last step is just to simplify. Now just use algebra just to simplify what you have. So 9e to the pi, I will still get 9e to the pi. Cosine pi, well, cosine pi is negative 1. And if you're not sure of that, plug that into your calculator. So if you forgot your trig, no worries. Put cosine pi, in here. And make sure the mode is in radians, not degrees. If you put degrees, it's going to be the wrong answer. So make sure it's in radians, and then you end up getting negative 1. So in case you forget your trig, plug it into the calculator. So here, negative 9 times negative 1 gives me a positive 9. E to the 0 here is simply just 1, so I have a minus 9. Cosine 0 is just 1, so negative of a negative 9 becomes a positive 9. Okay, so what do you know? Things nicely cancel out, or not cancel out, they zero out, so my answer in the end becomes 9e to the pi plus 9, and I box my final answer. Next problem is this. So here I'm going to go a little bit faster without explaining too many of the steps. So here I'm going to take the antiderivative. So antiderivative of e to the x is just e to the x. Here, the antiderivative of this, I'm going to add 1 to the x. So I have 5 out here. I'm going to add 1 to the exponent and divide by the new exponent. So again, that's how you find the antiderivative. You add 1 to the exponent and you divide by the new exponent. And this goes from 2 to 3. And again, even though I'm trying to go a little bit faster, I still want to check my work. If I take the derivative of this function, I get e to the x minus 5 6. I multiply the 6 out in the front, and I subtract 1 from the exponent. So I end up getting e to the x minus 5x to the 5th. Ta-da! It's the same thing as that, so that works. So next, I'm going to use the fundamental theorem of calculus. And again, I'm going to do the same thing of putting brackets around here minus another bracket. So this is going to be my f of b minus my f of a. B is a 3, and a is a 2. Okay, so when I plug it in, I end up getting e to the third minus 5 6, 3 to the 6. When I plug in the 2, I get e squared minus 5 6, 2 to the 6. Okay, so now I just need to plug things into my calculator and simplify. So at this point, this is the algebra work. So when I do this, I get e to the third minus this thing. I just encourage you guys to use your calculator to do all the algebra work, because I'm assuming your teacher or me, that I assume that you guys know how to do fractions, but just go ahead and save time by plugging that into your calculator. So I would do 3 to the 6, enter, 729, times 5 6. So times 5 divided by 6, enter. I get a decimal answer, and we want things to be in fractions, so I put second fraction, and I end up getting 1215 over 2. So minus 1215 over 2. So don't waste time trying to do it by hand. I say just use your calculator for the sake of time. Minus e squared, a negative and a negative becomes positive. 5 6 times 2 to the 6. So I'm going to do the same thing, 2 to the 6. Enter gives me 64, and I multiply this by 5 6. So 5 divided by 6 right there. I get up 53.33, change it to fractions, I end up getting 160 over 3. Okay, so now e3 minus e squared, remember that does not become e to the first, right? Because these are not the same terms, they're not like terms, so you can't combine them. Negative, but what I can do is I can combine negative 1215 over 2 plus 160 divided by 3. And remember to put parentheses in when you plug into your calculator. I end up getting that ugly answer, so I change it to fractions, becomes negative 3325 all over 6. And that, my friends, is our final answer.